right, guys, sorry I had to stop that. But let's finish up our examples here. So we had just finished up the first one. The second one, looking at it, it looks like standard form here, which again is kind of our least favorite form to graph in. Because it doesn't give me any information right away. I have to do a little bit of work for it, but it's not too bad. So what we do is we want to find our x-intercept, and to do that we ignore y, so like it just goes away, and we write down what we have left. Now the reason it goes away is because we're really plugging in 0 there, and so that's why it disappears. And so the x-intercept would be at 3, so you can go on the x-axis and graph that. Then I kind of do the reverse where I find the y-intercept, so I ignore x, and so we have 3y equals 6, and so the y-intercept is 2, so we can plot that, and then we can get our line. Super cute. Oh, there it is. Super cute. Alrighty, on to the next. The next one that I have here is almost y equals mx plus b. It's so close. I just need for that y to not be negative. So you can divide the negative away. I'm going to just multiply it away. It kind of does the same thing. So if I multiply negative 1 on one side, I fully need to do that on the other. So negative x minus 2. And then we can just find our y-intercept, which when we're in slope-intercept form like this, the y-intercept is the number not on x. So negative 2. And then our slope is the number being multiplied to x, which is a negative 1 over 1, just so we're always thinking rise over run. And so we plot our 0, negative 2, and then we do our slope of down 1 over 1. We can do that as many times as we want. We can also do up 1, backwards 1. And again, it's important to keep in mind that we only do one negative thing. If I do 2 negative things, then I've accidentally made my slope positive, and we don't want that. Alrighty, this line here is unique because all the other lines have both x and y. And when I have both x and y, you're going to get a diagonal line. If you only have one or the other, then you're going to get either a vertical or horizontal line. And when you have x equals a number, that one is always a vertical line. Feels kind of opposite because x goes horizontally, but literally what this is saying is that no matter where I go on my graph, x has to be 3. So like I can't go here because x isn't 3. I can go here because x is 3, but I can't go over because x won't be 3. I have to go only up or down for x to be 3. So those are all the places where x is 3. All right, just 2 more. And this next one here is back to standard form. So looking like this one here. Not so bad. I said that I hate graphing it, but it's actually not so bad. You just do have to do a little math though. So we're going to find the x-intercept by ignoring y. So negative 3x equals 12. So x is negative 4. And go plot that point. Then we do the opposite, find the y-intercept. So I ignore x. Make sure we take the sign with y. So negative 4y equals 12. And so the y-intercept is negative 3. Plot that. And then we can connect our 2 dots and go. The last one that I have here for you guys. It's tempting to think that this is kind of in point slope form because it does have parentheses, but it kind of has 2 sets of parentheses, which none of these do. So this is just kind of a mishmash, and you probably just want to simplify it and put it in y equals mx plus b, honestly. So to do that, we're going to distribute on both sides. So we'll have 2y minus 8, negative 3x minus 6. So like if it's not automatically in any of the forms, I usually go y equals mx plus b. So I guess that's why it's the good old standby. But if I can put something in point slope form, I'm all for it. So we'll add that 8 over for 2. And then we have to get y all by itself, so we're going to divide everything here by 2. So negative 3 divided by 2 is negative 3 over 2. And then 2 divided by 2 is 1. Then when I go to graph in my y equals mx plus b form, I'm going to plot my y-intercept at 1, the number not on x. And then I'm going to do my slope of down 3 over 2 to the right to keep it positive, but actually negative overall. Or I can go up 1, 2, 3, back 2, and there you go. Little line in the other direction. You'll love to see it. Okay, so your homework is a lot of graphing. There's a couple of them on there where you're going to graph 2 lines on the same, because if you remember, that's really our goal here. We're trying to find where 2 lines intersect each other. And yeah, good luck. I'll see you guys later.